myself Shweta Shah. I am your instructor for the subject Computer Organization and Architecture. In this subject we are going to start today the unit 7, that is Computer Arithmetic. And in this unit we are going to see today the topic Addition and Subtraction. So before starting with the topic, let me see what are the outlines for this unit. These are like addition. First we will see the addition and subtraction operation. Then we will see the multiplication algorithm and division algorithm. Then we will see the floating point arithmetic operation, and in which we will see the addition, multiplication and division for the floating point numbers. Then we will see the decimal arithmetic unit. So let first we start with the first topic, that is addition and subtraction. Here addition and subtraction with sign magnitude data can be given like this. If you have two numbers like A and B, and these numbers are sign numbers, that can be A can be positive or negative, B can be positive or negative, then we can do this task. Addition task can be represented as a plus B, and subtraction operation can be represented as a minus B. Here for addition A is organ and B is a addend. And for subtraction, A is a main hand and B is a subtrahend. Here for the operation, it will depend, actual operation, whether you have to do addition or subtraction, which will depend upon your given operation and the plus the sign of your numbers. If your task is of addition and any of one number is a negative, then ultimately you will do the subtraction operation. Similarly, if your both numbers are negative and your operation you given is also subtraction, then you will do the operation of addition. Okay, so it will depend upon two things, that is your numbers sign, whether it is positive or negative, and second thing on the operation, whether you are given the addition operation or the subtraction operation. So if we consider this total 8 operation, that is your number can be positive or negative and operation can be positive or negative, then we can summarize it like this, whether you are going to do the addition operation or subtraction operation and what will be the sign of your result. Okay, so we can give it like this. If your numbers, both numbers are positive and you are given the operation of the addition, then you will actually do the addition operation. Your result will be like A plus B. That is the simple thing. Okay, if your given numbers A is positive and B is a negative, operation is of addition, then you will do the operation A minus B. Okay, that means you will do the subtraction operation, but the sign will depends upon your content of your resistor. If it is A is greater than B, then your sign will be positive. If it is A is less than B, then your sign will be negative. And if your A and B both are equal, then your result will be 0. But sign we can say as a positive. Okay, so it will depend upon your number, whether it is positive or negative and what operations are given. If we consider that your A number is a negative and B is a positive and you are given the task of addition, then also you will do the operation of subtraction, that is A minus B. But sign will depend upon A and B. If A is greater than B, then your sign will be negative. If A is less than B, your sign will be positive, and both are equal, your result will be 0. Or you can say positive A minus B. For all of this equal, we will consider this A minus B is positive. Next, if your number is A is a negative, B is a negative, and your operation is of addition, that means you are going to do the operation of addition, because minus minus is plus. You are going to do the operation of addition, that is A plus B, and sign will be always negative. Okay, for this case your sign will be always negative because both of your numbers are negative, but operation will be of addition. Next, if we consider for the subtraction operation, if your A and B both numbers are positive and operation is of subtraction, that means you are going to do the subtraction operation, but sign will depend upon your A and B. If your A is greater than B, your sign will be positive. If your A is less than B, your sign will be negative, and both are equal, then positive A minus B, that is same as 0. If you are given the operation of subtraction and your A is positive and B is negative, that means you are going to do the addition operation, because here minus minus will become plus. So your operation will be like A plus B. And similarly, if your A is negative and B is positive but operation given is a subtraction, That means minus A minus B. Actually you will perform the addition operation, but the sign of your result will be negative. That will be minus A plus B. And similarly for the last case, if your A is negative, B is negative, and operation given is the of subtraction, that means you are going to do the subtraction operation, but result will depend upon whether your sign A is greater than B or A is less than B. If your A is greater than B, then your sign will be of negative. And if your A is less than B, then your sign will be positive. That means your sign will be of B, and B is having positive sign. Okay, so your sign will be B, or you can say positive, B minus A. So in short, we can say that your operation of addition or subtraction, you can't say just by the operation whether you are given the addition operation or subtraction operation. You have to also check the sign of the number. If you are given the addition operation and both of these numbers are positive or both of these numbers are negative, then you are going to perform the addition operation. But any of one number is negative and operation is of addition, then you are ultimately going to do the subtraction operation. Okay, and sign will depend upon your number. And similarly for subtraction operation, if you are given the subtraction operation and both of these numbers are having the same sign, whether they are positive or whether they are negative, then actually you are going to do the subtraction operation. But your sign of any of one number is different, or you can say one number is positive and one number is negative, and you are given the subtraction operation, then ultimately you are going to perform the addition task. Okay, so that you have to check the sign of the number, whether these numbers are positive or negative. How you can represent the sign of number? By the MSB bit. Okay, if your MSB bit is 1, that means your number is negative. If your MSB bit is 0, your number is positive. And you have to check for these two numbers, whether this both are 1 or whether this both are 1 or 0. That means if both are 1 or both are 0, that means your numbers are both are positive or both are negative. And if it is 1 is 0 and 1 is 1, that means one number is positive and one number is negative. You have to check whether these two signs are 0 or 1 or 1 0. For this we can use the XORing. Because in XORing, if your both numbers are equal, that is 0 0 or 1 1, your output of the XOR gate will be 0. And if it is 1 is 0 and 1 bit is 1, then your output of this XOR gate will be 1. So that you can find out whether this number are having equal sign or not equal sign. If it is having equal sign and the task is of addition or subtraction, then you will do the addition or subtraction operation. But sign is different and you are given the addition task, then ultimately you are going to do the subtraction. And if you are given the subtraction operation, sign is not equal, then you are going to do the addition operation. Okay, so we have to check this also. So you can represent it like this: 0 XOR 0 is 0, 1 XOR 1 is 0, and if it is different sign, that is 0 and 1, then your XOR gate's output will be 1. So depending upon this output or this condition, you can decide whether you are going to do addition operation or subtraction operation. Here the hardware implementation is given. Here we are using this resistor B with sign bit BS, resistor A with its sign bit AS. Okay, here that is this whole AS and A is combined is A resistor, BS and B combined is a B resistor, but we have represented this BS and AS differently because we have to compare this BS and AS by means of some XORing, whether the sign is equal or not. Okay, after this A and B resistor, you have some parallel adder, and if you have subtraction operation, then you have to use this mode bit. For the subtraction operation, we will use the 2's complement method, and for this we have to do this complement operation. Okay, so for this B resistor, we have used this complementer with the mode selection. If it is subtraction, then you will do the complement operation, and input carry will be 1 for this parallel addition. And if it is addition operation, then you will use directly that number. Here mode bit will be 0, so that your number will be directly over here, and input carry will be 0, and simple this addition task will be completed by this adder circuit, and this output is going to be generated into, or you can say output is going to be stored into resistor A with sign in AS and with E flag, that is your carry flag. And that is also going to be stored into overflow flag. Here AVF represents the overflow flag. Okay, so ultimately your result is going to be internally stored into accumulator and E flag, and externally you can see this into this overflow flag and accumulator resistor. So this is the basic hardware structure, where if your subtraction operation is there, then you will use this mode control as a 1, and then you will complement this number so that you have 2's complement of that number by putting this input carry as a 1. Here complement is done, but for adding 1 we have to use this complement carry, or you can say input carry. So you can use the same circuit for addition and subtraction operation by just simply selecting this mode bit, and here BS and AS is for your sign bit. For the operation we can use this kind of flow chart. Here for subtraction operation we have main hand in the A resistor, subtrahend in the B resistor, and for addition operation we have AND in the A resistor and added into B resistor. We have to check for the sign. If your addition operation is there and both numbers are having same sign, that means if you do the AS XORing BS, that is same, both are same, that means both are 1 1 or both are 0 0, that means output of this XORing will be 0. So if your XORing output, if your addition operation is there and XORing of your sign bit is showing 0, that means your both number are having same sign, that means you will do the addition operation. Okay, but if it is different, that is XORing's output is 0, then you will do the subtraction operation. So it will go over here. Here we have, in this block we have done the subtraction operation. In this block we have done the addition operation. Addition operation, your result is going to be stored into EA, that is A resistor and E flag. As A plus, B and E flag is ultimately going to be stored into overflow flag, that will be shown in the last figure. Okay. If it is subtraction operation, if it is 1, that means you will do the subtraction operation. So for this subtraction, you have to add the 2's complement of B, that is B bar plus 1. So your operation that is going to be stored into E resistor will be A plus B bar plus 1, that is equals to A minus B. Okay, and your overflow flag will be 0, because in subtraction operation you will never generate the overflow. Okay, so overflow flag will be 0. And for the subtraction operation, if your sign is equal, then you will do the for the subtraction operation, if your sign is equal, then you will do the subtraction operation. If it is not equal, then you will do the addition operation. So if sign is equal, then subtraction. If not equal, then addition. And in addition, you will do the same task for with whatever you have used for the adding. And for subtraction, you will do the same task for this. For subtraction, we are using the 2's complement method. In 2's complement method, after adding the 2's complement of the subtrahend, if carry is generated, then your number is okay. That means your result is okay. If carry is not generated, that means your number is negative and represented into 2's complement form. To represent actual number, you have to take the 2's complement second time. Okay. So for that, we have to check for the E flag. If your E flag is 1, that means your number is positive, but it can also be 0. Okay, so for that we have to check for the A resistor. If content of this A resistor is 0, that means you have to put the A sign as a 0, because for 0 we have used the positive sign, so that we will put AS as a 0, and if it is not 0, then already it contains a sign with it in AS. Okay, for 0, that means E flag is 0, that means your number is negative and represented in 2's complement form, and for that you have to represent in second time you have to take the 2's complement. For that, load this number, or you can say complement this number, that your result that is stored into accumulator, complement this number and then add 1 into it, and we complement this sign, because sign should be as it is. Here in complement your sign is already changed, but that you doesn't require to be changed, that you will second time you will complement it and store into A's. Okay, so by this way we can represent your addition and subtraction. If your addition operation and sign is same, then you will do actually addition operation. If your addition operation sign is different of both number, then you will do the subtraction operation. Similarly, for the subtraction operation, if your sign is the same, you will do the subtraction operation. Sign is different, then you will do the addition operation, and after the subtraction operation you will check for the E flag. If it is 0, then you have to do second time 2's complement for the actual result, and if it is 1, then your actual result is given in the A register and overflow flag. After that you have to check for the 0. If your result is 0, then you have to put the sign flag as a 0. Otherwise, if it is not 0, then your result is already in A and AS register. Okay, so your result finally stored into A register and AS, and if any overflow is generated, then it is stored into overflow flag. So by this way you can use this addition and subtraction operation for your numbers. This number also can be represented into 2's complement. Here we have used the sign number, but if we represent these numbers into 2's complement form, then we just require to do the addition or complement operation. Let me see how we can represent this. Here, if we represent this number into 2's complement form, then we just require this register A that contains your second number and this first number. Then you will just require this complementer and parallel adder. If any overflow is there, then your overflow flag is generated. Here we doesn't require to check for the sign that we required in last case. If we represent in a sign magnitude form, then we have to check for the sign. But if we represent this number in a 2's complement form, then we doesn't require to check for the sign. Okay, so just we require to complement and just parallel addition. That here that is same. A accumulator's content will be accumulator plus B, or if your subtraction operation is there, then accumulator's content will be like accumulator plus B dash plus 1. That is your subtraction operation, and then result is going to be stored into your accumulator and V flag, accumulator and V flag for both the case, addition and subtraction. So it will become simple as compared to the sign magnitude, because we doesn't require to check for the sign, because we have already represented this number into 2's complement form. So here we are ending our today's session. If you have any query, then you can contact me.